Given that you all like the video spinorial so much, I thought I'd show you something else you can do with cloth. This is an iterative method for folding a tie into 3 without having to judge it by eye. I always get it wrong. So, what you do is take your tie, black tie, and you divide it into 2. Divide it like that. I'm going to do it really uneven just to prove a point. You divide it into 2, you hold it at the fold at the top, then you take the longest length and you bring it up to the top fold, the top mountain fold if you're into origami. Then you hold the valley fold at the bottom here, the bottom fold, hold it tight and let go, so the tie flops down. Then you see what you have, you take the bottom length again, the longest length, bring it up to the mountain fold, hold the valley fold and drop it. Keep doing the same thing, taking the bottom longest length, holding the valley fold and dropping it. And eventually, if you keep doing it enough times, I'm going to speed up here, just for the purposes of saving your time and mine. If you keep carrying this out enough times, the tie will fold itself into 3. I'm going to do one more after this and show you. Look at that. Perfect. You can do it like just by eye, like a normal person, but you'd rather do it with maths, right? So let's try and get an understanding of how this works. What I've done is I've split the 3 different parts of the tie fold, 1, 2, 3, into X, Y, and the last letter of the alphabet. I've given them each a value, which is proportional to its length, so 0.2, 0.4, and 0.4, because obviously when you make the first fold like that, and you do this, 2 of them are going to be the same. What I've also done is I've made it so that one of them is about half the length of the others, just to represent these numbers here. Now, let me show you what happens after each iteration. You can see the numbers happening here, and you can see them getting close to 0.333 and 0.333 and 0.333, which is our desired outcome. So we've got 0.2, 0.4, and 0.4. What I do here, when I hold the bottom fold, is I'm adding 0.2 and 0.4 together. There we go. This is now 0.4 and 0.6. And when I bring this up to the mountain fold, I've averaged them. I've added them together and I've halved them. So I take the mean of these two, 0.3 and 0.3. Then when I hold the bottom here, add these two together, 0.3 and 0.4, drop, you get 0.7. And you bring the bottom up to the top, divide by 2, 0.35, 0.35. So what we're doing is we take the average of these two, then the average of these two, then the average of these two, and the average of these two, and so on and so on and so on. And you can see how naturally and intuitively this means they'll eventually be divided perfectly into 3 equal parts.